Okay, good afternoon also from my behalf. So yeah, my name is Antti Soikkeli and I work in Tekla Corporation, and I'm located in our headquarters near Helsinki. So yeah, first I have to want to thank you, the organizers, to be here, and feel the privilege also to present the new technologies that are already available. So then shortly about the agenda. So first introducing our company, then speaking a little about the challenges that the companies in construction industry are facing today in their operations. And then after that, some possible solutions that are already available. And then after that, a couple of example cases from the customers that we have. And then a short summary, of course. And then I will go quite quickly through the presentation, but we also have a booth outside the conference room. So if you have any questions in your mind and have let's say, more deep discussions, please come to the booth and have a discussion with us. So, Tekla Corporation, we develop and market software products and services for business processes in construction and energy distribution and infrastructure management. Tekla was founded in 1966, which makes us one of the oldest software companies in the world. In July 2011, Trimble Navigation acquired us, so now we are part of Trimble. And we have, let's say, over 700 employees, which is located in Finland. And also we have over 20 offices globally around the world. Good. So, as my time is limited, I will go straight to the point. So then, according to the common project management theories, let's say there's a scope, time, and cost, which are, let's say, affecting to the quality of, let's say, any project. And as we are talking about the construction industry, I would like to, let's say, split the quality in two things. So it's there's, let's say, quality of the product and quality of a process. With the product, I mean the building itself, or let's say any man-made structure. It can be bridge also. And with the process, I mean the process, how the building is being built. So then if we think, let's say, more carefully about the product and how the cost is coming, there's this kind of common theory of life cycle cost, where 1 represents the capital cost, the construction, 5 represents the, let's say, the maintenance using the building, and then 200 represents the operational costs, which means, let's say, all the costs that are needed to successfully operate the business inside the building. So, and this is a theory. And actually in this slide I have a true example from Finland. So there was a new hospital project in Finland where 10 million euros was used for design and construction management, and then 100 million euros for construction, and 4,000 million euros for the operational cost was estimated for the 40 years time period. So maybe the true life is not that radical than the theory was expecting. So that was the, let's say, product side. Then if we go to the process. Generally, there's a challenge, and there was a research. So it was made by Finnish Research Center and Skanska together, that in construction side, only 30% of the time is used actually for production. Then let's say the rest 70% is used, let's say, for waiting, or let's say it's going for the transfer. So it's both of those are a little bit, can be called as waste. So then this graph, so then in other businesses there has been, let's say, significant increase in productivity. This is other businesses, and this is more like the construction industry. But in construction industry, as you can see, the productivity level has been remaining the same, or let's say decreased a little bit. Small note, however, it's not totally true, I would say, because there's a prefabrication that is done off-site. It's not included in this, so it's like a little bit not on the top. But then I think this graph is demonstrating the waste actually a little bit better. So the red line is actually there's some mistake. So it's a product price index in the construction industry, the red line, and actually the blue line is the consumer product price. So as you can see, there's a 30% difference, and from where the extra 30% is coming from. So it's ineffective communication, planning, and collaboration that are mostly let's say, the source of the problems. So then about the solutions. BIM, let's say, is the most potential paradigm at the moment that the modern technology can provide. It can be, let's say, seen as a solution to improve the quality both on the product level but also on the process level. BIM is actually an acronym which means Building Information Modeling, Model or Management. Depends on the, let's say, research or thing that you are reading on. But then what is BIM? At the moment, the BIM is seen as a database that contains essential data and information that is required for construction processes. But I would say that BIM is much more than that. This is a McLeamy curve, and it represents how BIM affects the design process as well how it affects to the costs. So not sure how good you see, but let's say the number 1 curve is the ability to impact the cost and functional capabilities. Then the number 1 curve here is the cost of design changes. Then the number 3 curve, it's the traditional design process. And then curve number 4 is the BIM design process. So as we can see, the traditional design process curve is going over the number 1 curve in the construction documents and bidding phases. So what this means? It means that most of the design is done on those phases, and still during the construction there are some design done. This means in practice that changes cause some problems at the site. Then on the other hand, if we check the BIM curve, most of the design is done in the schematic design and design development phases. So this means that almost all the design is already done on the bidding phase. So no more changes on the construction phase. Since the data plays a critical role in BIM, there's a certain characteristics that it should follow. According to Building Smart, BIM is about sharing open, structured, semantic, and data in a standard format. So how the BIM data, what it should be? So it should be accessible for everyone. It should be processable. It should be understandable, and it should be in common format. So far I have been only presenting the technical core of BIM, which is only actually part of it. BIM is a, let's say, socio-technical system, which also includes the social part. This means that BIM is much more than just the technical core that is usually the reference. It is a combination of man-made technology and the social and institutional consequences of its implementation to society. So in Finland, let's say Finland has been the leading country in implementation of BIM all the way from the beginning. Let's say though now we are challenged by the UK, which has set target to be the leading BIM country by 2016. UK strategy includes several things. For example, cost savings over 30%, shorten the delivery times, and reduce the emissions 50%, and then significantly increase the export 100%. But then, although we are the world leaders in BIM, we have been only focused on creating the information, which means that the digital product models already exist a large scale on the market, but we are not taking any benefit from the information itself. So still, most common way to communicate is through drawings, and only the design phases are using BIM and the BIM benefits. So then, how to use the information in the value chain? In the physical model phase, model information is being created in a constructible level. This means that it includes, example, rebars and embeds. And it's usually like the engineering offices, engineering bureaus who are doing that. Then in the process model phase, process information is being added to the model. This means that the schedules, or let's say construction sequences, are being created. Then it's usually like the fabricators, precast steel fabricators. Then the information users phase, information is mainly used, but also different comments and statuses are being added to the as-built model. Then this can be contractors, or then the municipalities or governments, whatever, who are using the information. So then, this slide is representing pretty much the same than the previous one, but let's say a little bit from a different angle. First, the information enables the automation, and automation of drawing creation is actually a really good example from that. But then, but slowly, at least in Finland, we are moving towards creation and usage of more extensive information, where information is used to guide the process and decision making. For example, in the BIM model, you have these kind of layout points, which you can then, with the total station, use on the site to confirm that it's on the right place. Then there are already at least few companies in Finland that have created totally new business processes and managed to question the existing processes in construction industry. So then, for the cases. As a first case, I have a Skanska. Skanska Finland has been investing a lot of effort to the BIM as a contractor. They are especially focusing on the process side of the quality. They have approximately 70 active BIM projects ongoing. And BIM, they use BIM at site, for example, glass checking for the visual examinations, quantity calculations, and so on. Last years, Skanska has been focusing on mobile devices, and a special focus on Tekla Field 3D. So at the moment, they have over 200 users on these kind of tablets. And actually last month we had a BIM forum in Finland, and as a keynote speaker we had Mr. Särkilahti, who is the CEO of Skanska Finland. He mentioned that one of the biggest benefits that they have realized are tablets with constructible models. According to Särkilahti, every manager on site who are using tablets are saving at least 4 hours in 1 week. So that's a lot of save. Tablets with models, constructible models, enables to get job-specific views, as you can see on the picture. And they have access, or let's say the site managers have access to up-to-date information all the time. Then, according to research and empirical experiments, the majority of people are incapable of comprehending the traditional plans. So, and additionally, 70% of the understandability of plans is lost when it's not on one-to-one scale. And because of these two reasons, Sweco has created the Sweco Cave. It's a user-centric functional design review and validation model or system. the Sweco cave is a key to reality. The user enters the 3D world with the field of vision exceeding 180 degrees. The 3D vision and stereoscopic imaging gives a spatial sense of space and depth. 1:1 scale gives a true life size and increases the understandability of the plans. So some benefits from the cave that Sweco has realized: better design solutions, a better workplace, more satisfied client. Design review and validation, less need for physical model rooms, and less need for design changes in the late design phase. No design changes in the construction phase anymore. And it helps in reaching the hard project targets also. So then the third case. Hinkley Point is the first of new built nuclear power plants in UK that will replace the existing fleet of plants that are due to decommission. The construction will be joint venture between Lane O'Rourke and the French Bouygues. Both are contractors. So the image you see here is around 20 tons of reinforcement modeled to check the constructability from a set of already issued for construction drawings from a similar project than Hinkley. So this small sample had more than 700 interference clashes. So it would have amounted a huge amount of rework on construction site. And by modeling the reinforcement in the design stage, there are huge benefits to reducing the construction waste as well as waste elimination already during the design phase. So then, actually, originally, intention of Lane O'Rourke was to model the reinforcement to check the constructability from the drawings. But during the evaluation process, they quickly realized that there was going to be a huge problem on the construction site. It was decided then that the reinforcement needed to be modeled in 3D on the design stage already. So then about the traceability. So by scanning the code in a drawing, then attaching the code to a bundle after cut and bend, and then it can be tracked on the site. Then when scanned at site, the bars are automatically located and highlighted in the BIM model. So we know exactly where they need to be delivered on the site. So that's good. And then once installed, then the installation date and other quality control information can be delivered back to the BIM model.
Last 1 minute.
Yep. So then Lane O'Rourke spent a lot of time with their guys thinking about how to move the installation into the 3D. And this has had significant payback. Some of the trial projects, they reduced installation times significantly. Then another initiative that Lane O'Rourke is pushing is new style of reinforcement drawings. You saw the complexity of the 2D drawings on the last slide. So, and utilizing colors and 3D views like this, the understanding and the problem is much more easier. In this case, let's say the old standard have not kept up to date with the technology. So yeah, heading for the summary. So now, in the beginning, I was introducing the life cycle cost principle. So now I can say that there is a way that can help, let's say, companies, municipalities, and governments to save a lot of money by investing in quality in design and construction management. Modern technology already provides the tools that enable project parties to reach the desired quality in their projects. Let's say, small investment in design and construction management phase will definitely help to reach the better quality process and save some costs already during the construction phase. But actually that's only a small saving, since most of the savings comes through the better quality buildings that are designed especially for the end user. So, thank you.
Thank you, Antti. And the guy is running with a paper airplane.
Yeah, giant one.
Okay. Do we have a quick question in the room? If not, then yes, we have. The front. Oh, the second row, please.
Thank you very much for this interesting presentation. I have two questions. The one is Autodesk has introduced also a BIM-based database which is cloud-based. So my question would be, what is your data storing strategy, so to say? Connected with this, what about data safety? And the second question is, what about property of data? The rights which are connected to information which is fed into the BIM database, how can these rights be protected?
A complex issue. Yeah.
The first one was, what was the first question?
What about the storage?
Oh, storage, yeah, the cloud. Let's say we, as a Trimble, we are part of Trimble, we are, let's say, there's solutions that are available soon for that. So yes, there's something on the development that is coming out. Let's say that. And then the second one was the
rights of data. The rights which are connected with data which is fed into the data.
The rights of data.
So how to access the information. So then, yeah, I think it's also related to the cloud kind of system. So then, but yeah, for example, this year we have actually now released new kind of system. It's called like a model sharing. So then it's the model is being actually downloaded to the cloud, and then the one who is creating the model can give access to almost anyone to access the model and do the detailing, or then just if it's like for the model viewing, then they can also view the model only.